This video recreates a talk which was first given over 20 years ago at Western University in London, Canada. As I have lost the use of my voice, I am using a synthesized voice on this video. The substance of the talk is the same, but a few small changes have been made, and I have added a number of hand-drawn graphics to help make up for the absence of both the speaker and his voice. We have all been taught that the Earth is a sphere, orbiting in the vastness of space about the Sun. But what most if not all of us experience in our lives is the essential flatness of the Earth. Of course, whether one is speaking of the Earth as a flat surface or as a sphere, we ignore the obvious departures from flatness, such as hills, river valleys, and mountains. These features, while enormous on human scale, are very small compared to the scale of the Earth itself. So although I personally greatly appreciate the drama and beauty of these terrestrial features, I will be ignoring them here. For my present purpose, it is far more important to look closely at what we find if we go to the sea. Here note the sharp contrast between the hills along the shore and the evident flatness of the water. In this picture of Lake Huron we are struck by the quite perfectly straight horizon, giving the strongest possible impression of the flatness of the Earth. We gain the same strong impression if we visit the sea in any part of the world. When we fly over the Earth in an airplane, this impression is not only confirmed but greatly strengthened. Could it be that this impression is correct, and that the conventional wisdom is wrong? When I was a child, my first acquaintance with the notion that the Earth was a sphere was in my book of knowledge, in an article entitled "The Big Ball We Live On." It cites as proof of the roundness of the Earth that a ship at sea can be seen to come over the hill of the round Earth. Let me read to you what the Book of Knowledge says. The Earth is not flat, but round like an orange. We know this by the way a ship comes into sight at sea. At first we see only smoke. Then we see the top of the mast, as if the ship were climbing up a hill. Then the bow appears, and we see the vessel rising higher and higher. If the Earth were flat, we should see the whole ship at once, not the mast first and the rest bit by bit. But we do not see it that way. We see the ship rising as if it were sailing up the other side of a ball. At last the ship is over the circle, sailing clear on the top of the ball. But frankly, have you ever seen this? I certainly haven't. Any ship I've seen disappears into the haze long before I could tell whether this effect had occurred or not. Well, I was musing on these thoughts recently, and found myself drifting off into a trance-like state. Now that I am retired, I have many more opportunities for such moments. The depth of this trance was so great that I seemed to enter into what might best be described as a state of direct knowing. In the course of this state the following truth was revealed to me. Revelation number 1, the Earth is flat. This revelation has transformed my understanding of physics, throwing everything into a different light. You must understand, this is a truth, not a hypothesis, so there is no question of proving it. It is a given, one of the underlying truths about the universe. Now this does not mean that previous experimental observations are wrong. I do not ask you to deny the evidence of your senses. But those experimental observations must be reinterpreted in the light of this new knowledge. That is the great work which has fallen to me through the gift of this revelation. In this talk I will share with you some of my preliminary findings. Before going on to those findings, I want to emphasize the contrast between this new knowledge and our conventional physical theory. The latter is, as you know, based on hypothesis, not truth, so of course it must bow to knowledge of a higher order, such as I have been privileged to have had revealed to me. I opened this talk by pointing out the evidence of our direct experience to suggest that the Earth might be flat. My musing on that evidence was, perhaps, the stimulus for the revelation that has led to this new worldview, but this is a truth, quite independent of that evidence. Indeed, there's other well-known evidence to suggest the apparent curvature of the Earth's surface. Here, for example, is a photograph of the Hawaiian Islands taken in August 1965 from the Gemini 5 spacecraft. Beyond the islands the clearly curving edge of the Earth is visible. What is going on? How can this observational evidence be reconciled with my newly revealed truth? The inescapable conclusion is that this curvature must be only apparent, just as the satellites only apparently orbit the Earth. Similarly, while we might actually be able to see the phenomenon illustrated in the sketches from the Book of Knowledge of a ship coming uphill around the curve of the Earth, any such observation must be only apparent, not real. My program therefore is to come to an understanding of how these and numerous other experimental facts of which we are all aware can be reconciled with the revealed truth about the flatness of the Earth. To overturn such a large part of previous understanding is a huge task. You will not be surprised to learn that so far I have been able to do little more than scratch the surface. Let me start by considering the ship on the sea. If the Earth is truly flat, then how could it be that the ship gradually comes into view, as if going around the curve of the Earth? By now you have probably guessed what must be happening. A clear and inevitable consequence of the flatness of the Earth is that light does not travel in straight lines. Let me show you in a qualitative way how this must work. In the conventional picture, shown at the top of the figure, more and more of the ship becomes visible as it approaches, and rays from successively lower points on the ship are able to reach the observer. The correct picture is given at the bottom. There you can see that the rays of light curve away from the Earth, as shown. The ship gradually comes into view as the rays that do not strike the Earth are able to travel from the ship to the observer along their curved paths. If a satellite is sufficiently far from Earth, a camera on board will see the Earth as a disk. The further the satellite is from the Earth, the more of the surface is seen, and the smaller the angle subtended by the Earth. This picture of Tibet was taken from the Gemini 5 spacecraft, which is quite close to the Earth. If the astronaut looked all around, he or she would see the Earth as a very big circle, with only a small section of the Earth's surface visible. This picture of the Earth was taken from Apollo 17, on its way to the Moon. Now the disk of the Earth is much smaller, but much more of its total surface is visible. The upper half of the next sketch shows the conventional erroneous interpretation of these observations. In that interpretation, it is the curvature of the Earth's surface that prevents you from seeing more than a small portion of the surface when close to it. At greater distances, the Earth appears as a disk because of its spherical shape. In the lower half of the figure I show the true situation. These changes in the appearance of the Earth from space are a natural consequence of the curvature of light rays in the vicinity of the Earth. When close to the Earth, the curvature of the light rays restricts our view to the region between, say, A and B on the figure. As we get higher above the surface of the Earth, the cone of rays that touches the Earth spans a larger portion of the surface, from C to D, while at the same time enclosing a smaller angle, so that the Earth appears as an ever smaller disk. That's all well and good, but you are no doubt checking off on your mental fingers innumerable problems that still must be addressed. What is the exact shape of the light rays? Is it actually possible to have them curve as described and not encounter a logical contradiction? Is the flat Earth finite or infinite in extent? If it is finite, what is its shape, and what is the nature of the boundary? How can satellites be in orbit over a flat Earth? How can the sun rise and set? I must admit frankly that some of these questions gave me great difficulty, for my revelation, great as it was, gave me no guidance in seeking an answer to these questions. Night after night I racked my brain without success until one night as I drifted off in a half-sleep I dreamt that I was outside in the middle of a field. It was bright sunshine, but large hailstones were drifting down like snowflakes. I reached out to catch one, and immediately it started to rise into the air, growing into a dazzling crystal sphere. I realized that I was witness to a second revelation, but what was it telling me? That the Earth is spherical after all. That some hailstones are actually precious stones? No, soon the upper half of the sphere turned translucent, and through that shimmering hemisphere I could see a flat plane, which formed the upper surface of the solid lower half of the sphere. Suddenly awake, I realized that I not only had the answer to my questions, I had the revelation of the configuration of the entire universe. Revelation number 2. The universe is a sphere. The lower hemisphere is the Earth, all else is in the upper hemisphere. With this revelation virtually everything fell into place, and the essential nature of the universe stood clearly before me. A quantitative description was now within my grasp. However, today I will restrict my presentation primarily to qualitative results, reserving the intimate details of my revelation for those who, with sincerity of purpose and devotion to the task, choose to work with me in the exploration of these revealed truths. This figure shows some of the key features of our universe. We see that the mathematical notion of the point at infinity actually takes material form, serving, in effect, as one of the poles of the entire universe. Since the whole universe outside the Earth is contained in this finite hemisphere, it is tempting to think of this as a sort of dome of the heavens. However, its actual nature is somewhat different. Things which we conventionally think of as being at greater and greater distances from the Earth are actually closer and closer to the point at infinity. I will not be saying anything about the interior of the Earth in today's talk, but I have indicated in this figure that what might be conventionally called the center of the Earth forms the other pole of the universe. If the North Pole is at the center of the Earth's surface, then the equator will be located as indicated in this figure. But what does this picture actually mean? How can it be reconciled with the fact that at any one time, people on different parts of the Earth's surface see different parts of the sky, directly overhead? The explanation lies in the curvature of light rays. The figure shows how the light rays arrive at different locations perpendicular to the surface of the Earth, even though all of them come along paths leading away from the point at infinity. However, from this picture it looks as if all the stars in the sky are visible from everywhere all of the time. This is not so, again because of the curvature of the light rays. Here is a cross-section of the universe. Consider for convenience 2 points on the equator, 12 hours, or 180 degrees of longitude apart, A and B. The darker shaded region shows the part of the universe visible from A. The star A' is directly overhead, while C', which is drawn as if it were the pole star, is on the horizon to the north. The lighter shaded region indicates what is visible at B. The star B' is overhead, and C' is also on the horizon at the north. It is clear from this figure that nothing in A's sky is visible to B, or vice versa, with the exception of the single location exactly over the pole. All this is in perfect accord with what we observe, just as it must be, if our description of the universe is to be correct. Another feature of our daily experience is that the sun rises and sets each day. According to the old interpretation, the sun illuminates half of the Earth at any one time, and as the Earth rotates, the sun rises and sets at different places on the Earth. The true explanation of these daily events is illustrated here. For simplicity, again consider 2 points on the equator separated by 12 hours, A and B, and assume the sun to be over the equator, as it is at the equinoxes. What is shown is a surface of rays coming from the sun which arrive tangential to the Earth's surface. All rays lying within this surface will strike the Earth and illuminate it. Those which are outside this surface will miss the Earth and continue on into space. As we would expect and require, only half of the Earth's surface is illuminated at any one time. As the sun moves clockwise in its orbit, daylight moves over the point A and the sun is seen to rise in the east. At the same time the region of darkness moves over the point B, and the sun there is observed to set in the west. Although we have shown the situation when the sun is over the equator, the basic explanation is the same wherever it is located. The situation may be visualized more clearly by taking a cross-section through this last figure, as shown next. Here you see only those rays coming from the sun which just graze the surface of the Earth and separate the illuminated from the dark regions of the Earth's surface. For point A on the equator it is noon and the sun is directly overhead. Point B is also on the equator, but the local time there is 12 hours earlier or later, and the sky overhead is entirely dark, just as it should be. Behind the Earth, so to speak, and extending off to the point at infinity, is the shadow which it casts in the light of the sun. Once again, we find that all features of the diurnal variation of light and dark are in accord with our experience. In fact, all familiar phenomena are readily understood in this new and correct picture of the universe. As another example, let me just take a moment to explain the phenomena of eclipses of the sun and moon. An eclipse of the moon occurs when the moon moves into the shadow that extends behind the Earth, as illustrated on the left of the figure. An eclipse of the sun occurs when the moon moves in front of the sun, casting a shadow on the surface of the earth. This is illustrated at the right. The moon's shadow covers only a small portion of the earth's surface, in agreement with the observation that solar eclipses are quite localized on the earth's surface. On the other hand, the eclipse of the moon is visible from a large part of the earth's surface, as is evident from the left half of the figure. Perhaps you are already wondering about artificial satellites in orbit about the Earth? This figure shows a satellite in what would conventionally be described as an equatorial orbit about the Earth. As you can see, everything is quite in order, with the satellite appearing overhead for people situated on the equator, just as it should. If we consider satellites in orbits with higher inclinations to the equator, we get an admittedly strange result. Here I show 3 different satellite orbits, all inclined at 85 degrees to the equator. These satellites have orbits conventionally described as being circular, and with radii measured from the center of the Earth of 1.5, 4, and 10 times the radius of the Earth. Not only are these orbits no longer circular, but as we would normally understand it, the orbits which are physically largest are actually the smallest. Nevertheless, they all pass overhead of the same points on the surface of the Earth, shown by the dashed line. It will not have escaped most of you that there will have to be a significant revamping of the laws of physics as we presently know them, if they are to conform to this new and correct understanding of the nature of the universe. As you might well imagine, this is a huge undertaking, and so far I have only been able to consider a few of the more obvious alterations which must be made. Let us start with Newton and his laws of motion. His first law states that every body must continue in its state of rest or uniform motion in a straight line unless acted on by some force. It is evident that this law must be changed. However, only a slight change is needed and then all is well again. In its revised form, Newton's first law reads, "Every body must continue in its state of rest or uniform motion in a light line unless acted on by some force." Here by light line I mean a line along which a ray of light will travel. Newton's second law is a little more complicated. Before we discuss it, it may be helpful to spend a few moments thinking about the speed of light. We know that light no longer travels in straight lines, but can it still travel with constant speed? It only takes a glance at some of the figures which I have shown you to conclude that it cannot. Consider, for example, the 85-degree orbits which I showed you a moment ago. The distance across the track of the orbits on the surface of the Earth is the same as the distance to an orbit at 10 Earth radii. Furthermore, the distance between the orbits at 4 and 10 Earth radii is about the same as between 1 at 1.5 Earth radii and the surface of the Earth. It is evident that the speed of light must vary both with location in the universe and with the direction in which it is traveling. We could characterize this behavior by introducing what we might call a fundamental index of refraction. The refractive index of the universe, n sub u, equals c, the speed of light at the center of the Earth's surface, divided by the speed of light for any particular location and direction. Thus n sub u has different values at different locations, and different values in different directions at any one location. With this definition, we are able to express the revised form of Newton's second law very simply. Force equals n sub u times mass times acceleration. I wanted to keep this talk simple, so I have been purposely avoiding equations, and the one equation I am presenting I have kept as simple as possible. However, I must explain that in the form shown here it holds only for certain special fundamental directions, for which the force and the acceleration are parallel. This is not always the case, and in general the refractive index of the universe is a tensor. That force and the resulting acceleration need not be in the same direction can be understood in general terms from consideration of the revised version of Newton's first law. Since an object with no force will, in general, follow a curved path, a light line, it will have an acceleration even in the absence of any force. A small force can be added in any direction, without affecting the natural acceleration of an object. From this we can conclude that force and acceleration can have quite different directions. Your minds may well be reeling already with the unexpected richness of the physical world around us, now spread out for our view for the first time by the prism of truth. But there is much more. During my discussion of the speed of light a few moments ago, your attention may have been attracted to the relative size of objects at different locations within the universe. For example, compare the orbit of the Sun in space with that of a satellite in near-Earth orbit. The orbit of the Sun and the Sun itself are considerably smaller than the satellite in its orbit. It is one of the truly wondrous features of our universe that objects actually change their size as they move through the universe, becoming ever smaller as they approach the point at infinity. Not only that, but the change in size is not necessarily the same in all directions. This leads us to consequence number 5. The size and shape of an object varies, with its height above the surface of the Earth, and with its distance from the pole. I will not go into the details today, except to note that there is a complementary variation in the size and shape of objects and in the variations of the refractive index of the universe, n sub u. Such a parallel is clearly demanded by any description of the universe which is to be in accord with experimental observations. The variation of the refractive index of the universe compensates for the change in size and shape of objects, and results in no apparent distortion at all, as of course must be the case since we observe no such distortion. A necessary consequence of these variations is that in general the laws of physics will also depend on the location within the universe at which the observations are being made, as well as on the orientation of the objects whose behavior is to be described. What a rich and intricate physics lies ahead for all those who wish to follow in the path of truth. Today we will not travel much further along that path, in spite of the innumerable possibilities that lie waiting to be explored. I have just a few final observations to make. The first of these relate to the fact that the universe is spherical. As I have been talking, you may have been wondering to yourself what would be seen if one traveled to the external spherical surface of the universe. Since the surface of the Earth extends right to that boundary, it must be possible to visit it, and yet we know of nothing unusual which we might expect to correspond to something as fundamental as the boundary of the very universe itself. In fact, it is possible to come arbitrarily close to this surface without being in the least aware of it. Essentially all light lines are tangential to this surface, so it can never actually be seen. The entire surface corresponds to what in our former view of the world would be described as a singular line extending out along a radius of the Earth at the opposite pole from the point which is at the center of the flat Earth. It is a mathematical singularity, and hence is quite undetectable. These effects were actually shown in an earlier figure, in which I illustrated how the light from the Sun illuminates only half of the Earth's surface at any one time. Here I show two of the rays from that earlier figure. These rays are headed almost exactly towards the singular outer boundary of the universe. At the very last minute they veer away, and after traveling almost exactly tangential to the bounding sphere, they rise up and away, heading off towards the point at infinity. In my talk to this point I have tacitly assumed that the center of the Earth and the singularity lie at or near the geographic poles of the Earth. This makes the presentation of the material a good deal more straightforward. However, there is no a priori reason for this to be the case, and part of the profound truth revealed to me is that the axis of the universe actually passes through the very center of Khufu's Great Pyramid at Giza. In fact, it is only within the most central of the inner chambers of that pyramid that the speed of light is isotropic, and exactly equal to c, the magnitude that we normally take to be its constant value everywhere. One very obvious question is, what lies outside the sphere of the universe? I can simply answer, I do not know. Many of you are no doubt appalled by what strikes you as a ridiculous description of the Earth and the universe, and view it as a completely unnecessary, arbitrary and hopelessly complicated description. In support of that view, one might point out that the conventional theory has already proven itself to give a very satisfactory description of virtually every physical fact known to us. My reply to such objections is the following question. Do you choose to reject a description of the universe which embodies revealed truth for an agglomeration of hypotheses whose only redeeming feature is that so far they seem to work? Thank you for your attention.